Hi, sixth graders. I'm going to give you another challenge. We just ended our chemistry unit by doing a little bit of an engineering project. And now that we're in the mindset of an engineer, I want us to continue moving forward with that by tackling another issue. Okay? So we're going to start out with this picture here. You can see there's a lot of penguins. Okay, they're all hanging out on this piece of ice. There's some swimming around it. And then over on the left-hand side, you can see that there's penguin tracks everywhere. And one lone penguin sitting on the ice. Now, what do you see as some problems with this? If you think about what a penguin needs in its life in order to reproduce and eat and protect young, what are some problems that they are going to face in this situation? Think about that for a second. All right, as we move on here, it's not really widely known that penguins are not just at the South Pole. That's not the only place they hang out. They actually hang out in other areas that are considerably warmer than Antarctica. You can see that wherever there's red on here are populations of penguins. But if you look on the western edge of South America, you can see that there's populations there as well, all the way up to the equator. And that is a very warm area, right? So they're not the same kinds of penguins. There's different species of penguins, just like there's different species of any other organism on Earth. But those penguins, wherever they are animals that need land, and they also need water. Okay. One particular population of penguins live on a beach in South Africa. South Africa is fairly warm. It's the narrow end of the continent, and so it gets a lot of the warm ocean air. Okay, so these penguins are hanging out on the beach, and the climate across the globe is changing. These penguins are getting a little bit too warm. To keep from overheating, they can cool off in the water, but this survival technique has not worked in their favor. Why do you suppose that is? If little penguins want to go cool off in the water, what do they become for some hungry animal? Right? A couple different things can happen. They can get eaten by sea lions. They can get their eggs stolen by seagulls. Look at that guy. He's walking away with one of his eggs. And so what engineers have done, and what research biologists have done, is they've made these little kind of like igloos, these little shelters for these penguins in order to keep them out of the sun, keep their eggs out of the sun, and give their eggs some protection. And there is a little guy inside one of these little houses. Okay, so climate change is causing penguins in Antarctica to become endangered by eliminating available habitats. And that goes back to that first picture, right? Those penguins are all sitting on one piece of ice. They can't get to another piece of ice without swimming. If they swim, they are more subject to being preyed upon by larger marine animals. They have to then maybe leave their young, or their young have to also swim, which is a dangerous situation. They have less breeding grounds. They have less area to spread out. Okay, so the sea ice breaking up is a problem for this particular species. And there's many signs, there's many pieces of evidence all over the world that we have a warming climate. And here in Minnesota, especially when we have a couple weeks like we did in February, where it is 30 below, it's hard to really accept this reality. However, we are in this system. Earth is surrounded by an atmosphere, and wherever we have hot temperatures in one place, we have cold temperatures in another, okay? And so the term global warming is kind of an unfortunate term because it makes everybody believe that everywhere around the world is getting warmer, and instead it should be maybe called global weirding, because what it's doing is it's just making weather strange. It's making warmer places warmer. It's causing some more severe droughts. It's causing more frequent and stronger hurricanes. It's causing all sorts of different things. Droughts in California give rise to a lot of wildfires, okay? And so here, we don't really have a controversial, or there really is no question that this is happening because we have evidence. Where the controversy comes in is, what is the problem? Like, who is causing it? Is it naturally caused or is it human caused? Okay, so in this project, we're just talking about the facts. We're just talking about the evidence. We do know that Arctic sea ice is going down. We do know that ocean heat is going up. Remember when we were learning about the coral bleaching, all of the coral reefs bleaching and dying at a very rapid rate in the last decade or two? It's because the ocean temperatures are so warm. And one of the reasons is that air over the ocean is also warm, so that overlying air is heating the water. The water is also a huge absorber of solar radiation. Okay, so that upper mile or so of water in the ocean is considerably warmer than it was decades ago. Our sea levels are rising because our glaciers and our sea ice are melting, right? If you melt off all of those huge glaciers that are above the water, our sea levels are going to come up a little bit. The air temperature over land is increasing overall. The humidity is increasing because a lot of water from the ocean can evaporate into the air. And when that happens, it's harder to keep humans comfortable. We use more air conditioning units. We use more energy. So all of these things kind of play into each other, and it kind of makes the problem a lot worse. Okay, so how bad really is climate change, and are we to blame, or is this a natural cycle? Well, that takes a lot more research than what we're going to do here, okay? All we know is these facts here, okay? And so given these facts, what can we do to help the organisms on this planet that are suffering because of this? Regardless of whose fault it is, or if it's a natural occurrence, there are organisms on Earth that are being affected negatively by this. So what can we do? Well, what can we do at home to help those penguins, those poor penguins that are losing their habitat and their safety and their food? Well, one big thing that we can do is save energy. When we use energy, we emit something called a greenhouse gas. And we have done a lot of studying in chemistry with CO2. CO2 is a greenhouse gas. Carbon dioxide is a greenhouse gas, and it is a product of combustion reactions. Okay, so those are reactions that take place in areas where fossil fuels are being burned. Okay, so fossil fuels being coal, oil, gas, that kind of stuff. Okay, so one of the products of that, remember we have the reactants on one side, the products on the other. One of the reactants is CO2. So we're adding that up into the atmosphere, and it's a greenhouse gas, meaning it has the same effect as a greenhouse. It traps energy, or traps heat energy inside the Earth. And when we increase that, we have naturally occurring CO2, and it's really important, or we wouldn't be able to live. Life as we know it wouldn't exist. It'd be too cold here. We have to have the greenhouse effect. But we're adding to it, and we're causing more heat to be trapped into our planet. Okay, so what are some things that we as individuals can do? Well, if you look at this diagram here, we have our typical energy losses in a home. 25% goes out the roof, 10% goes out the windows, 15% is lost through the floors, 15% through the drafts, and then 35% through the walls. Well, what season do you think this is, and what do those arrows represent? What do you think? What's in our house that leaks out that causes us to use more energy? Especially here in Minnesota in the months of October through May. The heat is what is represented by these arrows. Where is it going? It's going into the atmosphere, okay? And we've got radiation, conduction, and convection. Those are three terms that we're really going to be talking a lot about this week. Okay, those are the three forms of heat transfer, how heat can move from one place to another. Okay, and then what time of year do you think this is? Probably winter, right? Well, what happens in the summer? Okay, we have energy gains. And this isn't really what we want either, right? In the summertime when it's really hot outside, we've got heat coming in through the roof. We have heat coming in through the windows, heat coming in through the floors, through the drafts, and through the walls in the opposite way, right? And inside our home, we are cooling it down either with air conditioning or with fans. And so we use more energy when more heat comes in. So one of the big things that we can do is pay attention to these things in our homes. Make sure that they're really efficient. Make sure that our windows are tightly secured. If we've got air conditioning on, certainly close the windows, right? Okay. So the heat is coming into the house in this picture. So we need to slow down heat transfer. Is what we need to do in our own lives. We need to slow down that transfer of heat. We need to keep the heat out in the summer. We need to keep the heat inside in the winter. Use less energy to heat and cool our homes. In other words, we need to stop those three words: radiation, conduction, and convection. And again, we're going to talk a lot more about what those three terms mean. And as engineers, my little sixth grade engineers, you guys are going to be constructing something to help these penguins survive a warmer climate. Okay, so you're going to be using different materials that minimize heat coming into their igloos and keeping them nice and cool and keeping their eggs nice and cool and safe from predators. Okay, we will talk soon.